Hi, my name is Mark Ryan. I'm going to walk you through building a AWS environment for Zscaler Private Access and Zscaler Workload Segmentation. So we've got a couple of Cloudformation scripts that are going to do this for us. I will start by building the scripts and then running through, building the stacks, running through what each of those stacks are doing. So we're going to create a stack and we'll upload a template file, and we're going to start with a script here called create SSM. And what this is going to do is build a systems manager parameter store for us, encryption keys, and store a number of parameters. So the parameters, we're going to call this create SSM. It needs to know an IAM username that exists. It's going to be the administrator of the keys, and then we're going to pass a number of parameters. The base URL for the API. So this could be config.private.zscaler.com. In my example, I'm using the beta cloud, so this is config.zpabeta.net. And then an API keys, the client ID, the client secret, and then your company ID. So those four things together enable us to call the API. So what we're going to do with this is we're going to create a parameter store, and we're going to store those credentials in the parameter store. So we'll click create stack for that, and then whilst that's running, I'll run through that YAML script, Cloudformation template. So there's the parameters. It's going to use KMS to create a key and set that username as the principal, the owner of it. It's going to say what we're allowed to do for those keys, creating an alias, and then it's going to do a bunch of things. We're going to create a function for lambda. And it's going to allow that function to do a number of things. So get the parameters, delete and update the parameters for two parameters. One we're going to call the Zscaler App Connector parameters and ZWS parameters, which we'll see in the next step. So we set a bunch of rules for that role in terms of what it's allowed to do. And then we create a lambda function. The lambda function is specifically there to encrypt parameters as you put them into the Systems Manager Parameter Store. Bizarrely, AWS gives you the ability to write things to the parameter unencrypted directly, whereas to encrypt them you need to use a lambda function. So this lambda function takes the data in, and then here it'll put those parameter with the encryption key and write them as secure strings into the parameter store. It's always important that we handle the deletes, so if we delete the stack, that it actually goes through and deletes those things as well, and actually returns a successful response. And then we call that function here with all those keys, and then we output a bunch of data. So if we come back here, hopefully now this is created. It's going to take a little short second to create the encryption keys and everything. Once this is completed, what we'll do is we'll run a second script which does exactly the same thing for ZWS, although we don't need to create the lambda function. So all this does is take the input for the ZWS key. So what this is doing is taking the private key and the public key or the certificate for your MTLS tunnel to ZWS. So here we need to put these into base 64 format. So you take your client key out to your PKCS12 and output that in base 64 format. You do the same thing for the public key or the certificate. And base 64 encode that, so we'll put those as inputs into our Cloudformation template. We've got a user, So client ID that's created and a client secret, we'll store that as well. And then we know our ZWS site ID because that's provided to you in the admin console. And then your root URL as well, in my case z.edgewise.services. And again, it's going to call that, saving the parameters using that same function that we created, or we're being created at the moment, and it'll store those into the parameter store. So let's refresh this. That's created. So what we'll do is we'll create a new stack with that ZWS template, ZWS SSM. We'll call that ZPA dash create ZWS SSM. And we'll create that stack. And that's going to error because clearly that reference didn't I should have used create SSM. So let's just quickly delete that. Create dash SSM. So we create the stack. Okay. Always make sure that you reference things correctly. I could build one Cloudformation template that references each of these individually. Obviously that would help me with any typos, but this one ran really quickly because all it's doing is calling functions that were created in this one. So what we can do is we can, looking here, we can go to the Systems Manager first. And we'll see these parameters have been created in the parameter store. So here are the different ones: ZWS cert, client ID, client secret, key, site ID, and URL root. That's what we just created. And these are the ZPA ones. They're all secure strings, and the role and the policy that's associated with my role means that I can't actually decode those because I don't have the right permission. So it's a good way to store parameters, making sure that only certain people or certain roles and certain functions have access to read them, to write them. So we're following best principles in terms of writing things to a parameter store and passing security credentials securely across AWS. We can also then have a look in Lambda. We've got our Lambda function, so we've got an application called create SSM that has a function in here, secure string, which is the one we used, and we can call this in any other function that we want to pass secure strings into the parameter store, and obviously making sure we got the right permissions on those files, on those credentials. Okay. So we've got our parameters now stored here. So what we're going to do is we create a new stack, and at this point I'm going to call one called create ZPA NAT Gateway, and we'll click next on that. Need to make sure that I call that correct. Create ZPA. So what we're going to do, we're going to span it across two availability zones. I'm going to select the two there. Of course, I could use placement groups and I could do a number of things to make this highly available, but this is the way I decided to do it. Just select two availability zones to deploy this. This will provide fault tolerance across those availability zones in the region that I'm in. I need to pass it two parameters, the domain name, that I've got associated with my AWS tenant, so that's welshgeek.net, and the hosted zone ID for that. And these two together mean that I can then start to create things in Route53 and making sure that these things are resolvable. We're going to stick with a T2 micro in this case because it's a demo and that's a free one. Obviously we wouldn't run that in production. From my key pair name, I can select the key pair that's available within this EC2 availability. And I'm going to create a couple of things. I'm going to create a public, two private subnets. The private subnets are where my app connectors are going to reside, and the public subnets are available from the internet, and this is where my NAT gateways are going to reside. And I'm going to create a new VPC for all of this to sit in. So it's important in this case I'm creating a new VPC. Equally, you could input a VPC that's existing and put subnets within that VPC. So again, I've done this for the purpose of the demo. There's a number of different ways you could achieve this. I don't need to do anything else with the stack. We've got all of our inputs here. Acknowledge that it's going to create some IAM resources and it's going to do a bunch of other things, and away that goes. So this is going to take a little while to run, in which case I will run you through what the Cloudformation template looks like. So again, we've got those couple of inputs there. Let's just double check that I got that spelt correctly for the input, so we're good. I give a couple of values that are available for those ZPA connectors to run as, so T2 micro or a C4, C5, M4, M5 instance types, which are the production instance types. I'm using a specific AMI that I've built for this, which is only available in East 1 and East 2, but of course you'd use the production ones that are provided by Zscaler. So we go across, create a VPC, set the DHCP options. For that, assign an internet gateway to it, and we figure out what the VPC ID is for that. What we're going to do once all of that's created is we're going to create two ZPA connectors, one in one availability zone, one is the other availability zone, and this is the user data that basically calls a script to provision it, the ZPA, and to provision ZWS as well on those connectors. So those are the two scripts that get called once the connectors are deployed. The connectors get deployed inside the private subnet, so they're only routable to the internet through the NAT gateway. They have no inbound connectivity to them, so we're following the defense in depth methodology. What we then do is we create a record set in Route53, which is the connector name and the hosted name. So we're going to dynamically register these in Route53 so they're DNS resolvable. We've got our private subnets, public subnets, and everything gets created. The route tables, the NAT gateways get created in the public subnet, and here are the NAT gateways getting created. There's not a great deal else that's really worth inputting. We've put a security group in here that basically says that the only ingress is from the private subnet into the app connectors. So this is a lambda function. The lambda function is the thing that's going to read the API variables, connect to the API, get the provisioning key, connector group and server group, and register everything within ZPA. So essentially, we're going to create a provisioning key based on the AWS availability zone, the AWS region, and the VPC ID. So once we know those, what we will do is we will pull the API keys out of the parameter store. We set all of those in a variable. we understand what region we are in. So based on the region that is passed to us in this parameter, in this lambda function, we can then say, okay, if we're in US East 2, we're in Ohio, or we're in US East 1, we're in Virginia. So when we register, we create a provisioning key in a connector group, we can correctly set the longitude and latitude for that connector group. So all we then need to do is log into the API and get the bearer token. We're going to set up a bunch of URLs here. One is to create the connector group, one is to create a provisioning key, one is to get the certificate, and this is an interesting one. So to get the certificate, the signing certificate for the provisioning key, what we'll actually do is do a search for one that actually contains the word connector. So if I come into private access here and look at my enrollment certificates, I've got one that's called connector. So that's specifically what we're looking for in this script. And then all provisioning keys will be signed by that certificate. This server group URL, everything's based upon that Zscaler base, so config.private.zscaler.com for production, your company ID to build up those URLs. And then we're looking for the server groups and the connector groups. So do those exist? And essentially, again, as I said before, we've got to handle the deletes. So making sure that when this function gets rolled back, we clean everything up correctly. But all we're going to do now is build that post data. We get the enrollment certificate ID. So we're looking for the function ID, the long 64 for that enrollment ID, and then we create a function, the connector group post data. To create the connector group, we're going to say the description is the region and the VPC ID. We know the AWS latitude and longitude. We give it a location name. We give it a name, which is the region dash VPC ID. And we set all the default upgrade times and everything. So we post that data in, we get the connector group ID back, and then we create the provisioning key data. We get the provisioning key ID back, and then we create a server group, and the server group contains the connector group. So all of this sets us up ready to deploy things, applications through these connectors. So any application we deploy behind these connectors can then be associated with that that server group. This function then calls this lambda function. We need to do a similar thing for Route53. Specifically, we need to be able to associate Route53 and disassociate Route53 with the new region that we've created, the new VPC we've created. So as you create a VPC, you need to associate it with the private Route53 instance. So we have to do that through a Cloudformation template that basically calls client disassociate and client associate VPC with hosted zone, post at the hosted zone ID, and we know the region, the VPC that we created. So it's important we call that. And then all we're going to do is we're going to output the DNS names of the two connector instances, and we're going to output the VPC ID. So let's just come back here and have a look if we've completed here. So we have completed the creation of ZPA. So if we come into EC2, there's some old ones, but we can see now we've now got connector 1 and connector 2 have been created. They were launched November 3rd, 11:28, so 6 minutes ago. It tells you how long I've been talking for. and they've been created in this new VPC that we created as well. And if we look at the tags, you can see that there's a tag being created on each of these, which is the connector ID. Connector ID was created by that provisioning script that runs on the connector. I'll just quickly run you through those provisioning scripts. So the provisioning script that runs on the connector essentially looks at the metadata to understand region, instance, and everything that it's running in. It then pulls those secrets from SSM. It's going to run as a certain role, IAM role. Again, it gets that data, the post data bearer token, and then it goes off and downloads the provisioning key, and then starts the process. And then what it does is it looks at the connector ID by reading the public certificate that gets deployed, and then sets a tag on the instance for the purpose of that. Okay, and at the same time, it's also going to install and run the latest version of ZWS. So it's the provisioning script runs the ZWS. It gets the parameters out of the parameter store for ZWS. It connects to ZWS and figures out the latest installer version, and then it goes ahead and runs that latest installer version and runs the setup process for that ZWS installer on the connector. So if we come over to private access here, provided I'm still logged in, we should be able to see two app connectors have been created. Connected at 11:30. They were connected with an app connector group, which is US East 1, so the region dash the VPC that we created, and we've got the provisioning key that's got the same name. So we can see that we've automatically done that. If we come over to Edgewise, let's log into Edgewise. I've got two instances that have been created in ZWS, which match 128.6 and 128.28. Those match here. 128.6 and 128.28. So those are the two instance IDs that we got created. There we go. The private DNS name. So those are registered in ZWS, and they're running the latest version of the software. Okay, so we've got all of that up and running. Was there anything else that we needed to look at? Oh, okay. So the only thing we haven't got are any application segments. These are the ones that were created before. But let's go ahead and now create a stack with the new resources, upload a new template file, and this one is called App Segments. Click Next, ZPA Segment. And we called the creation stack create-SSM. Reason for this is it's going to read the lambda function and the lambda function names, and we called the other one create-ZPA. So we click next on that. In fact, I'm just going to double check what I called them. Create ZPA, create SSM. Okay. Okay, and we're going to say port 22, we're going to create an admin port and a user port. User port really doesn't make much sense in this specific example for the app connectors, but this is setting us up for being able to do this for any application that we deploy in AWS. So we're going to click next on this, click next, and go ahead and create that stack. And whilst that runs, I will jump into the app segment lambda and run you through this. So we've got the input parameters here. And what this essentially does, so we can create the segments in ZPA, segment groups, and the policy to allow access. So when we call this function, effectively all we're doing is calling it with the parameter keys that we stored in ZWS, and then we're passing it any number of FQDNs, let's say. In this case, it's the DNS names for each of the app connectors. And we're also passing it an admin port and a user port. So if this was a web server, you might pass it user port of 80 or user port of 443 and an admin port of 22. You might do the same for a database, an admin port of 22 and a user port of 1433. And obviously this could be adjusted for your specific environment. And then we pass it the VPC ID because the VPC ID and the region helps us figure a bunch of things out where this is going to run. So we take all of this, we read through all those parameters to create the bearer token that enables us to log into the API. I'm going to skip the deletion because it's kind of obvious, but we're going to deal with the create. What we're going to do, we're going to search for whether or not this function's been called before. Is there a segment group already called AWS user? Otherwise, we're going to create a segment group called AWS user. The same is true, we're going to create a segment group called AWS admin if one doesn't exist. We're going to figure out the name of that server group because we created a server group called AWS-US East 1- and then the name of our VPC. So we know the server group, and then we can create an application segment where we know the segment group we created up there. We know the FQDNs because we passed those in, so it can pass any number of FQDNs into this variable. We know the server group, which is advertises the connector group to access these application segments, and we pass it the user port 80 in this case. The same is true for one we're going to call the admin segment group, so the ones that are port 22 access, we'll create those there as well. And then what we need to do is create some policy, and all we do in this case is I create a policy object that says if the app segment group is either admin or user, then allow access. Action is allow. And again, you might say if we pass this function a group name, we could say group administrators are allowed access to the admin segment group, and group users are allowed access to the user segment group. So this is setting up for any number of different processes to call this. Once that's all done, we're good to go. So we come into Zscaler Private Access now and refresh this page. We now have an AWS admin segment and an AWS server segment. They both appear to have the same FQDNs, but in this case, it's these ones. The admin segment says port 22, and in this case, we've got access to port 80. Obviously, app connectors are not running on port 80. These are in the different segment groups, AWS admin and AWS user. And if we go to the access policy, we've got one called AWS created, which is what we just called, and it says segment group is AWS admin or AWS user, allow access. Okay, so what that means is we can log in here, mryan@welshgeek.net. I'm going to sign into the beta environment. Just to demonstrate something other than AWS, I'm authenticating against Azure AD. So I should be all connected. ZPA, ZIA. Not that ZIA particularly matters for this example, but so we're connected here. So let's just come back over here to the application segments, and I've now got a connector here. So all I need to do is pass it my PEM file, say admin at, and the connector ID as we've got it registered in Route53, and I'm now able to access it, and I'm on 128.28. The only other thing I didn't show you, so 128.28 here is this one. And if we come into Route53, so I've got my hosted zone. I go into the right one, private, and here are my two connectors that that got created there. So hopefully that shows you everything in terms of creating systems management parameters, passing those parameters to lambda functions to retrieve API keys for Zscaler private access and Zscaler workload segmentation, using that to deploy app connectors programmatically, putting those into ZPA, putting those into ZWS, and then dynamically creating policy based on those functions. And we've now got those lambda functions here that we can then call from anything else, whether that's to create new segments, create those provisioning keys, to store things in the parameter store, or just to call them update in Route53. Hope that's useful. Any questions, let me know, mark@zscaler.com.